Okay, so what we're going to do starting B3, I thought I'll go over some of the homework and talk about it in case if you need any extra help. So in this homework, the first one, which is number 20 in textbook and one for this homework, we're going to practice everything, base, acid, and arrows. So in this one, the author is asking us to look at the conjugate base for the acid. So if you're looking for an acid, this is a branched Lowry acid, remember the H plus? So if you're looking for an H, so would be my ammonia, the H for ammonia would be here. So we're going to remove that as an acid. For water, we have two H's. One of them we're going to use. For the hydrogen, there are two H's. We're going to use one of them. For this external alkyne, we have two of them, and they are the same, so we take this one. From methanol, we have H attached to the O, we take that. And the last is the hydronium ion. So we have all these basically H plus that we need to remove. So these are the acids. So these are the acids. Once you remove the acid, then you're going to make the conjugated base from those acids. So I'm going to conjugate base from those acids. Now the base, you can select any of them or any base. I decided to select water as a base. So for a base, we're looking at the electrons. Electrons for us is the base. The electron is going to remove the H as a H plus from the acid. How we're going to show that is with these arrows. So we say the electrons here going to make a bond to the H. Again, this is just to help us. Then the electron between the H and nitrogen would go back to the nitrogen in this case. In this case, it goes excuse me, to the oxygen. In this case, it goes back to the H, the other H. Here it goes to the carbon. Here it goes back to the oxygen. Here it goes back to the oxygen. So the base that we had as water is going to gain those H's. And nitrogen, oxygen, hydrogen, and carbon and oxygen gain the oxygen here, gaining the H. So the conjugated acid for these bases for the ammonia would be NH2 minus. So remember we lost that H. So this is conjugate base. For water would become OH minus. For hydrogen gas is going to be H minus, which we call a hydride. For the alkyne, so it would be the salt of the alkyne. So now carbon would be negative. For the oxygen methanol would be oxygen minus. We call this methoxide. And in case of the hydronium ion, basically you're going to make the water, basically. You're making the water. So when the water in this case, all in this case is gain that hydrogen as a H plus, because we use water, they're all going to make, all reactions they propose here are going to make hydronium ion. So hydronium ion basically is water that has extra H plus. And here's the, got all together, so here's the hydronium ion. Oh, sorry, didn't show it. Here it is. So a couple things we learned quickly here. One we learned is that a Lewis branched Lowry acid is a H plus. So an acid would lose an H plus. Acid would lose an H plus. Base, on the other hand, gain that H plus. So we use water as a base, and electrons are what they're going to accept that H plus. So that's the reaction. Now again, an acid by losing that H plus is going to make a conjugate base. Base by gaining that H plus make a conjugate acid. So this is a balance. Acid base always make a conjugate base and conjugate acid. We make sure that the charges are okay. If you have a negative charge, you have to have a positive charge, because on the left side of the equation we don't have any charge. So they have to be balanced for all of these. Okay, so in the second problem that we're looking at is number 3. So we were asked to look at this different bases, no, not acid, the base. So again, for us, a base is something that grabs a H plus, and in next definition we're going to learn is something with the electrons. So if we have something with unshared electrons, that is really a base. Again, like we did before, we identify the base first. So for the HSO2 minus is O minus. For water is oxygen with electron. For amine, this amine here is a nitrogen here, a primary amine, and amine is nitrogen. For carbon negative, now again remember, now you're looking at the carbon with extra electron here. It's not very clear, but this is a carbon with extra electron. So that carbon with extra electron is the base. Carbon with extra electron is the base. In the acetate, got a little bit small, but the O minus here, O minus is the base. So we identify all the bases for this series of problem A to F. And then again, the O minus, nitrogen, nitrogen minus, carbon minus, and O minus, they're all bases. So they're going to grab a H plus. So the arrow has to go from the O minus, carbon minus, to the H, which is the acid part. And the electron between the H and oxygen, in this case, goes back to oxygen. For the water reacting with the hydronium ion, so we use hydronium ion in all these cases to react with our base. So water react with the hydronium ion, we show there's an arrow going to the H, and bond between the hydrogen and hydronium ion goes back to oxygen to make water. Same thing for the nitrogen. Nitrogen is a base here, react with the, takes the H plus, and the electron goes back to the oxygen. Same thing here. Now in this case, nitrogen is negative, has extra electron, grab the H, electron between H and oxygen goes back to the oxygen. Carbon negative here, grabs the H, and this goes back to oxygen. In this case, the last case, bring it up a little bit, also to grab the H. Oh, I forgot to draw the arrow. So again, the electron between the H and oxygen goes back to the oxygen. So because of all this movement and making new bonds between the base and the acid, we're going to make a conjugated acid now. So we have a base, 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 and a base. Back here, base. So they're all going to make a, move this up a little bit. So they're all going to make a conjugate acid. So we have a conjugate acid for each of these. we're going to have a conjugate acid. So the conjugate acid, the difference now between the base and the conjugate acid is that H plus. So now they all have now H attached where the base was. In this case, it was oxygen. Same thing here. For the nitrogen, remember nitrogen was an H now. For the N minus, it's an H here. For the carbon minus, was a CH now. And for this oxygen here, now it's an OH. Now, our acid, all of them was hydronium ion. So the hydronium ion, losing that H as a H plus, and a conjugate base for the hydronium ion is always going to be water in this case because we use the same acid. Then we were asked to look at the strength of these bases. Strength of these bases. So we're going to learn this in this chapter that the strength of the acid that we made. I'm sorry. So if you start with a decent base here, not very strong one, but it makes a very strong acid. The next one is hydronium ion from the water. Then we have the acetic acid made from the acetate. Then ammonia, the nitrogen compound. And the last but not the least is the alkanes. So alkanes are not very good acid. They're not very strong acid, and they're very stable.